Alright, so today we're going to start our new unit called Rational Functions. So you have your table of contents, you can put that into your notebook. The handout that you received, just a simple fold it, not quite in half. That way you can kind of see your, put it this way, see like your little title here. And we're going to complete this today, and then you'll have a homework assignment. So, if you can open this up, we are going to get started with just a little intro about rational functions. So I'm going to kind of turn here and pause the video as needed to copy down whatever information you need. Okay, so first, a rational expression is an expression that can be written as a ratio, aka fraction, of two polynomials. Okay, an expression that can be written as a fraction, or excuse me, as a ratio, aka fraction, of two polynomials. So when you look at all of these examples down here, these are all examples of rational expressions. Okay, it's called an expression and not an equation because we don't have any equal signs here. We just have single fractions. Both the numerator and the denominator are some sort of polynomial. Okay. Because we're dealing with fractions, we have what are called excluded values. We have numbers that can make the expression undefined because we know we cannot divide by 0. So we have to pay attention to these excluded values. So an excluded value is just a number that makes a rational expression undefined. Okay, then finally, a rational expression is in simplest form when, I'm going to put it over here, the numerator again, the numerator is the top, and the denominator also known as the bottom, have no common factor. Other than 1. They'll always have that common factor of 1. Alright. So the first thing we're going to do, if you take a look back at the front, we're going to talk about those excluded values. Then we're going to talk about dividing out a monomial, dividing out a binomial, and then recognizing opposites. Okay, so let's first talk about excluded values. So when we're talking about excluded values, we want to take a look at the denominator. So for number 1, our denominator here is 6x. And you're going to take that denominator and you're going to set it equal to 0. Or I should say 6x cannot equal 0, because if it's equal to 0, then we are undefined. So we're going to solve for x, so we divide both sides by 6, and that means x cannot equal 0. So if x were equal to 0, we would have 0 plus 2 over 6 times 0, which is 2 over 0, and that's undefined. So we can take any other number we want. Doesn't matter what it is. We can plug it in for x, and we're going to get some sort of answer. The only one we cannot plug in is 0. So that's how we do excluded values. So let's take a look at number 2. Again, we're going to look at just the denominator. And we're going to say that cannot equal 0. And then we're just going to solve for x like we would any other equation. Sorry, I don't know why my focus isn't working here. Subtract 12, so 3x is not equal to negative 12. Divide by 3, so x cannot equal negative 4. Okay, let's take a look at number 3. Take that denominator, x squared minus 4, that cannot equal 0. You can either factor this as a difference of two squares, or you can recognize that we can solve by square roots. I'm just going to solve by square roots. So x squared cannot equal 4. Take the square root. The square root of 4 is 2. Whenever we take the square root, we take the plus minus. So x cannot equal the plus minus of 2. Okay, then the last one, we're going to take that x squared minus 3x minus 10 is equal to 0. Okay, not equal to 0. And we need to factor that. So what multiplies to give us negative 10 adds to give us negative 3? That's a negative 5 and a positive 2. So that means x minus 5 cannot equal 0. And x plus 2 cannot equal 0. Therefore, x cannot equal 5 or negative 2. Doesn't work for either of those. Okay, so now let's take a look at the next set of examples, talking about dividing out a monomial. We've been doing that for quite a while now. Dividing out a monomial, that's just another way of saying factoring out the greatest common factor. So if we take a look here, number 5. Oh, and it also says to state the excluded values. So first we're going to take a look at that denominator. 3x cannot equal 0. Therefore, x cannot equal 0. That's the first part. Okay. The second part is we're going to look for the common factor. Well, if you look, both the numerator and denominator have an x. So we can cancel out those x's. And when we cancel out those x's, we have a 1 remaining on top. Because remember, this is like saying 1x over 3x. So we have a 1 left on the top and a 3 left on the bottom. So this simplifies to 1/3, where x cannot equal 0. We have to consider before we actually simplify. Okay. Number 6, take your denominator, 2 times the quantity x minus 3, that cannot equal 0. Therefore, x minus 3 cannot equal 0. Therefore, x cannot equal 3. Okay, so that's the first part. Second part, we want to take a look at our numerator and denominator. Our numerator and denominator, they both contain a common factor of 2. So we can get rid of those 2's. So on top, we have an x left over. On the bottom, we have an x minus 3 left over. Now, it looks like we have that common value of x on top and bottom, and we do. However, these are no longer factors. X is a single term, but the x in the denominator, it's a part of this binomial. It's not a factor, so we're not allowed to cancel out those x's. So our simplified form is x over x minus 3, where x cannot equal 3. Okay, number 7. Again, take that denominator. It cannot equal 0. So x squared cannot equal 0. Square root of 0 is just 0. So x cannot equal 0. All right, so let's take a look at this numerator. In our numerator, we have a common factor. So just cover up that denominator for a moment. We have a common factor here of 5x squared. So we're going to factor that. When we factor out that 5x squared, or divide out that binomial, we're going to be left with an x plus a 2. And this is over 20x squared. So now in the numerator, 5x squared is a factor, x plus 2 is a factor. And the denominator, 20x squared, is a factor. So here, we can cross out the x squareds. Those are gone. And we can simplify 5 over 20. 5 over 20, when we simplify that, is 1/4. So we get 1, hold on, I gotta find some space here. I'm going to go over here. So on top, that 5 goes away. We're left with an x plus 2. And on the bottom, the 5 goes into 20 4 times, so we have a 4 on the bottom. Okay, so that's for number 7. Okay. Number 8. First do your excluded values, so look at that denominator. X plus 7 cannot equal 0. Therefore, x cannot equal negative 7. Looking at the numerator, we only have one term here, 3x. In the bottom, we have 2 terms, but this is considered to be one factor, okay? Nothing in common. We can't cancel anything out, top or bottom. So this one is already simplified. All right. Number 9 says simplify the rational expression if possible. State the excluded values. Okay. First thing we're going to do, we're going to factor the numerator and the denominator. So x squared plus 2x minus 3. So what multiplies to give us negative 3 adds to give us 2. That's an x plus 3 and an x minus 1. Over, okay, let's look at our denominator, x squared plus 8x plus 15. What multiplies to give us 15 adds to give us 8. That's an x plus 5 and an x plus 3. Let's talk about our excluded values. Where do we look for the excluded values? We look at the denominator. We have 2 parts in our denominator. X plus 5 cannot equal 0. Therefore, x cannot equal negative 5. And x plus 3 cannot equal 0. Therefore, x cannot equal negative 3. So those are the exclusions. What's in common, top and bottom? They both have this binomial of x plus 3. So we can cancel those out. So then we're left with x minus 1 over x plus 5. Number 10. Again, we're going to factor numerator and denominator. So in the numerator, what multiplies to give us negative 8 adds to give us 2. So that's x plus 4, x minus 2, over x squared minus 4. That's a difference of squares. That's an x plus 2, x minus 2. Let's talk about exclusions. X plus 2 cannot equal 0. X minus 2 cannot equal 0. Therefore, x cannot equal negative 2 or positive 2. That's your exclusion. Okay, what can cancel out here? We have common factors of x minus 2's. So we can cancel those out. We're left with x plus 4 over x plus 2. All right. Last part here. Running out of space. Let's see here. There we go. All right, we're going to do the same thing. Start with your numerator, see if we can factor. Here we can factor. We have a common factor of 3. That leaves us with x minus 3. In the bottom, we have a common factor of 4x, so we can take out a 4x. And that's going to leave us with 3 minus x. Okay, so you'll notice here, now we have, well, first, exclusions. 4x cannot equal 0, and 3 minus x cannot equal 0. So that means x cannot equal 0 or 3. Okay. Let's go back over here where we factored. So we have x minus 3 and a 3 minus x. Those are very similar. These are called opposites because they're exactly the same except the signs are different. Where the positive is positive on top, it's negative on the bottom. So we can do what's called factor out a negative 1. So what we can do is we can factor out a negative on top, and then that makes the inside binomial switch. Now we can cancel those 3 minus x's. So on top we're left with negative 3. On the bottom we're left with 4x. Okay, number 12. Factor your numerator. Multiplies to give you negative 12, adds to give you negative 1. It's a negative 4 and a positive 3. Does it matter if you put plus 3 and then minus 4? No, it doesn't matter the order. On the bottom, difference of squares. So 4 minus x, 4 plus x. Let's take a look at our exclusions. 4 minus x cannot equal 0. 4 plus x cannot equal 0. That means x cannot equal 4 or negative 4. So if I look right here, we have an x minus 4 and a 4 minus x. Those are very close. So what I can do on the top, I can put a negative 1 in front of that x minus 4 and then switch it. You only switch one of them. You don't have to switch them both. So now we can cancel out those 4 minus x's. So we have a negative quantity, x plus 3, over, and on the bottom, if you don't like the 4 before the x, you can switch it, x plus 4.